Okay. So, hello everyone and welcome back to the yet another live stream. Again, yesterday we looked at, we kind of finished, in quotes, the IOU report for our HTTP server that's written in Odin. Yeah, I mean, we didn't really finish it, but we got it to somewhat work. When I thought about the idea that we add our write calls to the IO submission queue as well, in my head I ran into a couple of problems that would lead to us restructuring our code. And even at the moment there are some bugs, but I really want to have everything on the queue. So yeah, we try to make that work today. Get everything on the queue so that the entire I/O is asynchronous and happens on the kernel thread. Yeah, I think that will be what we are doing today. We will see how far we can go. Okay, so what do we have to this point? Let's revisit that. So go 1 second. Go here. Excalibur. Okay, so what we have to this point is, again, we have our kernel thread, and we have our user space thread, user space thread, and we have the submission queue, SQ, and the completion queue, CQ. And whenever we issue an IO, for example, an accept on the server socket, we put that on the submission queue, the kernel thread reads that, and then if there is a connection to accept, it puts it on the completion queue, and we read from the completion queue and see that we accepted something. We get the client file descriptor out of it and start to issue a read on the client. We acquire a connection, and then we read from the connection. We issue a read on the submission queue, and whenever that's available, the kernel will read and put it on the completion queue. Then we handle the connection, and then if there is an HTTP message to be parsed, we parse the message and we write the response. Currently, the response is not written to this queue. But I want it to be the way that I want this to be to also go into the submission queue. So we also want the write of the response or send to go onto the submission queue. The problem is, if we pull from this completion queue, we now do not know whether this completion entry, where does the completion entry come from? Because the client file descriptor is now not sufficient to identify it. Where does the completion queue entry come from? We only have the connection IDX, which is not sufficient to distinguish between reads and writes. From the same connection. Now, how do we go about this? The first idea that I had was to introduce a connection command or something like that to the connection. And this tells the main loop, what am I? Did I issue a read? Or did I issue a write? And what do I have to do with the connection afterwards? This should be also tied. So what do I have to do with the connection after the command, the IO is completed? Because this is also a problem. We may write to the connection and want to close it, but we may also write to the connection and not close it. Because, for example, there's something else on the buffer. So that's a problem. So maybe there's a command that's write and close, and write and keep alive. But what we also have to consider is, what if multiple writes are in flight? What if, for example, a client send a buffer that's available with two HTTP messages. If we have a write and close, when we see that here, complete on the completion queue, we have a problem. Because we then close and the second write may fail. So we also have to introduce something like a responses in flight. Oh. Response says in flight. So only if that is 0 we can close. Right. So we could name this read again, or just read. That means we need to read the last thing that our read issued. This is like the initial thing. And then write and close, and write and read again. A write issued, read again. We could also make this kind of a bit set. So this is something like U32. And then we have a flag for read issued. Or read, what would be the right thing to... Okay, we could name this connection flags. Read and close. So read and close should never be together, but whatever. Then write or send. What would we need? So we need keep alive would mean that we have to read again, right? Right. So this would replace this. So there can be read and close. No, there can't be read. There can be read. There can be read and write. So this would be or write and read. And write and close. Correct. This would be something that we could do. Is that a good idea? I don't know. And also we then need these responses in flight. U32. Let's try and do that. But first we have to fix another issue. that is, let's turn off this light here. The next issue we have is server loop IO uring. We have essentially a bug here. That is if, yeah, we have to change this entire interface, but if this handle connection returns a not a dot close, we don't read again. So to do, we don't read again if the connection should be kept alive. That is a bug. Okay. So maybe let's revisit. So revisit this. Let's introduce something like responses in flight. Maybe this is part of the writer. Maybe not. Okay. And when we reset this, we say, okay, con.responses in flight is also equal to 0. And now we want something like, okay, connection flags, which is a bit set connection bits, which is an enum u8. And we have a read, a write, and a close. What happens if we have a read? If we read first before we write the response, it shouldn't really be a problem, right? If we overwrite the buffer, yeah, this is a problem, right? We cannot have multiple responses in flight, right? That's not really possible because we have only one buffer. If we overwrite that buffer, we have a problem. So if we issue a write and then another write with the same buffer, yeah, we have a problem. So we have to wait until wait before the next write, before the write is available. Okay. we have to wait. This is a problem. This is a serious problem. So this wouldn't work. We would need multiple buffers. Yeah. So we would have to wait until this thing is actually ready. I don't like this. So but what I want to do is, okay, let's just comment that out for a second. Let's say yeah, how do we do this? So if there are multiple, yeah, we cannot have two responses in flight because we have only one buffer. That wouldn't work. Yeah, so the write has to be a syscall. Is that right? Or the send? The send has to be a syscall. I mean, it would be nice if we could just have it on the I/O ring as well. But this would, then we would have to redesign this entire thing, right? I think that would require us to redesign the entirety of our program. Is that correct? So when we have two HTTP messages, in our buffer, I mean, we could just write them into the same buffer. So we could write the responses into the same buffer and send them both out. That would work, I guess. We could write the responses into the same buffer and issue a single write. Yeah, I think this is reasonable. And then if we, so in that case, only one response can be in flight. And that would solve the problem. Okay, so that would mean in HTTP, when we do an HTTP part, HTTP, no, it's handle connection. We cannot flat out just write the response if we have a message. Oh, but we also have only one header map, right? Write response. So write response. Write response. Maybe write response just does not do all of this, but rather we have something like a writer flush. Writer flush. That takes in the client connection. So this does not return an error now. This returns nothing. Writer flush. But when do we send this out? When do we send this out? Becomes the question. So we have to, okay. Handle request, write response. Connection reset. So in this case here, we don't want to flush the writer. When we break out of the loop, we have to check we can check the parser state. No, we cannot check the parser state, right? Because the parser state can be overwritten by the second message. So we have to do something like so this write response should go away. No, this has to stay, but we have to say, okay, we have some bool that is flush or should flush, and this is false. When we have even one complete message, we said should flush. So this is with a complete message, we said should flush should be true. And here as well, should flush. We could also do it in the writer. If something has been written to the writer, we can just, so we can put this on the writer. No. Yeah, we can put this on the writer. So should flush is a bool. And whenever we say so where was that? Where was that? And write response. Whenever that's called, we can say con.writer.shouldFlush is equal to true. In connection reset, we say con.writer.shouldFlush is equal to false. And then here, so shouldFlush goes away. So if writer, con.writer.shouldFlush, we writer flush. Con. And the writer flush is this. No. Don't ever return here. So this can return bytes written and I32 and Erno. Send TCP and return. $350. Writer flush proc. Okay. So this should help us. This should help us. Now, we can only have one response in flight. So, we need some connection flags. Put them in here. Thank you for the follow. Okay, and then in http.odin, handle connection, we don't return anything anymore. But we set the con.flags equal to dot close. Issue read write issued. Yeah, I don't know. This tells the main loop that we want to read again from the connection. We want to read from, okay, this tells the main loop that we issued a write or a send call to the client, a response send call. And this tells the main loop that it should close the connection after it consumed a write from the response write. This can only be used in combination with writes. This cannot be used in combination with read. We cannot tell it that we want to read and close. That doesn't make sense. Okay. Okay, so yeah, I think that's reasonable, but we could also make this an enum, but okay. So the connection has now this flags field. Now we have to correctly set these flags. So this would be a write and a dot close. And a request, write response. What do we return here in this case? Not sure. So how do we append to a bit set? Bit set. How do we do this again? There was some kind of union of bit sets. Bit set. Oh yeah, there was. In, not in. No. Used in bit sets. What was the operator for this? How do you add something to the bit set? In, not in. Okay. I thought you could union of two sets. Okay, that would work, I guess. Okay, right response. What? Should this also just set the right flag? Writer flush. Or should this set the right flag? I mean, in reality, this should set the right flag, right? So con dot right, no, dot writer dot should, no, not con dot flags or equals dot right. So whenever we do that, oh no, there can be a read and a write and a close. No, I don't think there can be a read and a write and a close. So in this case here, we have to set this to, so con dot flags or equals dot read. But how do we then identify from which? How do we identify what the completion queue entry has? Okay, let's HTTP parse cannot return an error, right? Handle connection. Con parser state. Complete message. In this case, we want to issue a new read, but how do we? How do we do this? How do we know what was the read and what was the write? We could also say, okay, we just, no, but I don't want to do that. Okay, so this will tell the main loop what to do. This is okay. So writer flush will set the write. Dot close. This should set con dot flags dot close. So this sets should flush and con flags write. Do we even need write? Okay, we could. What we could also do is take this out. Take this one out and say, okay, we just set the flags and whatever happens, happens, right? Okay, so maybe we take this out here. So we don't need a should flush. We just say con.flags or equals dot write. And in connection reset, we say also, so this doesn't exist. Should flush goes away. We just say con.flags is equal to the empty set. Something else that we miss? Okay, so in handle connection, so write and close. If we have a close, and a close can go with a write, can never go with a read, right? So let's just assert here dot read in con.flags. So close in con.flags, and so this implication. And dot read in con.flags, and then a not here. Is this really true? Yeah, we can only say, okay, we want to write and then close. Or we can say we want to write and then read and read again, because we had two requests. I think that is correct. So I believe. Okay, so this now is not a switch anymore. Okay. Now we have to check the flags. So client con.flags. If dot read in con.flags, we want to issue a new read. Oh no. So for this, we also adapt this for the ePOL API. I first want to fix it in the IOU ring. Server loop, yeah. Okay, so we handle the connection. And now we have to check the flags. So if, we can also switch con.case .read in con.flags. So this is getting tricky because we have to check whether there's a read and a write. So case read, because we have to distinguish between read and write, only read, and write and close, and only close. So this would be read in con.flags and .write in con. This is how we want to do this. So if there is a read, we just issue that read. This is also not correct because we here forgot to clean up the connection. We forgot to clean up the connection, which is necessary. But here it is not. Here, same thing. So if we got a read, how does it work again? It was like this, right? Okay, case.write. We have to somehow distinguish between the two. When we submit this, I will go and pee, go to the toilet, and be right back. Okay, so I think we did something wrong. I think we call connection reset with offset. We call connection reset with offset here. But we don't want to destroy our flags field. But that does destroy the flags field. No flags. Because this will destroy the flags field. So in connection, no flags. We cannot destroy our flags fields, because that will break the entire thing. Because if we get a request and we want to tell the main loop, okay, hey, read again, or hey, write please, yeah, that would break our system. So connection reset, no flags. The question is, do we use connection reset anywhere else here? No. Okay, that's good. So because write response will set the write flag. This will set the close flag, and this will set the read flag. Okay. Now go back into HTTP Linux here. Yeah, here we have to manipulate. So we have to distinguish between when we put something. When we put both reads and writes on the submission queue, we get both the read and the write result back from on the completion queue. So how do we know whether we got a read or a write? That is something we have to consider. So case write. Case.read in con.flags. In con.flags. And if we have a close and no case.close in con.flags, because if we have a write, let's just assert dot write not in con.flags. I don't know if that switch, I mean, it should really do that, but whatever. Okay, so if we get a close without a write, we just straight up close the connection, which is this. Close, connection reset, and pull release. So there should be nothing else to do. But here, I mean, there is a, no, this is also not correct. This is if, let's make this an if. If this is there, and if this is here, if right is set, and if dot close is set, and dot right not in flags. We could also make this a basic switch statement, but maybe this is easier. I don't know. We could make this an else if dot close in con dot flags. This should, there shouldn't be an, yeah, it shouldn't be nothing. I don't know. Okay, so now we have to construct something that resembles what the command was. So what we could do is we could say this is the command io uring command, or yeah, io uring command, and this is a bit, how did this work again? A bit field. Yeah, bit field u64, and we say okay, is this the first 3 bits or is it the last 3 bits? How is it? What is it? Most significant bit or a least significant bit first? Okay, let's make a quick test. Test.odin package main and main proc, and we have test bit field u64, and we have a first u32 which is 32 bits, and the second u32 which is also 32 bits, and we set first, so we set test bit fields or whatever, foo is equal to test bit field first is equal to 1, second is equal to 2. Let's foo 64 is equal to u64 foo. Okay, let's compile this. Odin builds dot, no, test.odin dash file dash debug dash o none. Undeclared name foo. Good. Okay, so we should have a test. And let's test.odin. Let's break at 9. Run. So print foo. format dot print line foo64. Break at 9, test.odin9, run, print foo64, print /t foo64. Okay, so, that was kind of stupid. Let's make the difference a little bit bigger, 255. Okay, so this is the second, right? So the second is so it starts least significant bit, right? Okay. So the least significant is the client file descriptor, which is a I32 or yeah, I don't know. And then we have the command, which is a connection bits. I don't know if that works. So so in test dot, let's remove test.odin again and make again. This is HTTP Linux 121. Okay, so of course this will fail, so but this wasn't what I wanted to do. Server loop IO uring. Okay. So the command is equal to a IO uring command with the con.client socket and .read. And then we cast this to U64. And here the command is equal IO uring command con.client socket with .write. Or is it even the client socket? No, it wasn't the client socket. It was the connection IDX. It's the con IDX U32. IO uring. So it's con IDX. Good. So this will be the command. Good. So we just OR the two values together. That is good. So I think that will do it. That means this is not the con IDX anymore. This has to be the command. The command is equal to IO uring command cque.userdata. And there's also a special one where it's -1. Just kind of reserved. I don't know. So I don't know if you can construct something where this would collide. To verify that the user data cannot collide. Okay, so the conidx is equal to command.conidx, and the uring command, ioring command, this is ioring command, and command is ioring command.command. This is the connection. And now we have to check what the command is, right? So switch the command if it's a dot read, a case if it's a dot and case, the default case cert false. So just panic, this should not be possible. So cert, oh whatever. Okay, so read. If this was a read, we want to do all of this here. Correct? I mean, we could do something like, okay, if cque.res is greater than or equal to 0, we do this, else we just close the connection. And take this, put it into the read. Okay, this is getting kind of convoluted. So if this was a read, if this was a write, though, we just have to check whether the flags of the connection says close. So if con.flags, so if dot close in con.flags, we have to close the connection. I think that's all of it. Let's see. Okay, so in server loop epoll, we now have to consider all of this as well. So handle connection, this will set the flag. So if, I mean, we just have to check, no. If dot write in con dot flags, we have to send TCP con dot client socket con dot client socket and the buffer, which is con.writer.buffer to con.writer.offset. This can return an error, so this is bytes written send error. If send error is not equal to dot none, I guess we just close this. And return. No, we don't return. We have to continue in the events, right? Where does that come from? If dot close in con dot flags. Let's event loop. So this would be a continue event loop. If the close is in there, if the read is in there, we just do nothing, right? Oh, we also want to do this here. Yeah. We also want to remove it from the epoll list. Okay, let's see. We don't need this. Expected an int. A bit field's specified bit size cannot exceed its type. Got 32, expected 8. Redeclaration of connection reset no flags. Why do we have that twice? Reset no flags, reset with offset, reset. Reset with offset no flags. Cannot determine. Are you kidding me? Why can't you determine the type? Because it's client con? Why do I name this client con? It's con everywhere. Yeah, con. con dot con no con command. This is the con idx is equal to this, command is equal to this. Client fd. This is the con.client socket. This is the con idx, this is the command. Call does not return a value, okay? Okay, so I think this builds. But I have no idea if this works. I'm able to submit accept call to submission queue. Great. Okay, this is something I have not expected. What? Okay, let's also something that's read write. Yeah, this was also wrong. So break one 159. Okay, what happens in there? LDB. Why does it take so long? Print the ring. Okay. Step into this. print the string flags. So it needs a wake up. CQ overflow is not in flags. Needs a wake up. eperm permissions what? How can this give me an eperm? IO uring enter. Man IO uring eperm return. This doesn't even say that it can return an eperm. How is that even possible? How's that even possible? eperm. Let's actually rerun this. I also wonder why it takes so long. Where are we? So it needs to wake up. Step instruction. Step. We make a syscall to submit. What is the flags? Flags. Need wake up. I thought that would be correct. U32. To submit. Enter SQ wake up. If the ring has been created, if the ring has been created with IO ring setup SQ poll, which is true for us, then the application has no real insight into when the SQ kernel thread has consumed entries from the SQ ring. This can lead to a situation where the application can no longer get a free SQ entry to submit without knowing when one becomes available, as the SQ kernel thread consumes them. Okay, so this is also something that we can use, but enter doesn't work. Enter does not work. I thought IO uring enter returns eperm. I wonder why. And it didn't do it yesterday. It didn't do it yesterday. Let's commit this. Changed API to call write from also in the epoll thing. Server, where was it? Server loop epoll. When we get a write, we did that. Okay, that's good. So quit to call write from the main loop and use flags in the connection. Changed IO API, moved the write into the main loop, introduced introduce flags to the connection, so that the main loop knows what to do with it. Introduced commands to associate a read and write call to a connection while being able to associate an IO call to a connection while being able to distinguish between reads and writes. Okay. So what I want to do now is roll back to this commit here. So git checkout this. Do a compile again. So Odin build dots. Okay, it doesn't work. Maybe something else. So I don't know why though. Git checkout head. Oh, git checkout main. Git restoration. eperm. Why does it return eperm? Syscall returns eperm. Okay, why does it return eperm? It didn't do it yesterday though. I wonder if I would restart my machine if it works. Oh man, this is kind of unfortunate. Why? I also don't want to end the stream at this point. Okay, so something is really, really bad. So maybe let's try and do it again. So this error message, I don't know where that comes from. And let's run this again. It takes so long, right? To set up. Why does it take so long to enter this loop? Entering server loop. It takes like 1 second to get into the server loop. Where's all that time? Where's all that time being spent? Initializing asset store. Done initializing. Is it before main? It's even... Is it before we even enter main? No. So we enter main. We do have a socket now. Why does this take forever? What takes forever here? Is it the arena allocator? Okay, let's step through the code. Yeah, it takes forever to initialize the pools. What? This wasn't the case, though. Why does it take so long? This doesn't make sense. To me, this doesn't make any sense. It shouldn't take forever to initialize the pools, and it didn't take forever the last time I checked. Well, well, well. Something is wrong. And I don't know what is wrong. I think this would be a good time to ePerm. Let's maybe step through let's maybe step through this again. Takes forever again. Let's go into the setup. SQPoll. Okay, print results. Print the params. Okay, this was filled. SQPoll, thread idle. I mean, we could circumvent this by setting this here a little bit higher. SQThread idle to maybe 10 seconds. But no. Still doesn't work, so this is so weird. Why does enter? I didn't change anything. Why does it return with ePerm? No, it's IO Urang enter. Where did I call this method? Here. This is kind of weird. Very, very weird. This is not what I was expecting. Maybe after restart it works again, but I don't know. Maybe the message. process start with executable stack. Usually that's something you don't see from the syscall. So something is very odd. Something is very, very odd. Okay, so what I wanted to do is, do I have this in my bookmarks? Raw performance. No. One second. So I want to build a profiler. I want to build a profiler where we can just time specific sections of our code. And I saw this profiler that was archived on the Game Developer Magazine archive. And it had this profiler from Jonathan Blow. And I wanted to look at this one and see if we can do something similar, or maybe we do something else. But I don't know at the moment. So let's maybe look through this. Let's maybe clone this. Quite large, actually. And let's just walk through how this works. Okay, so move. What was it? February 03 blow GDMAC profiling. Okay. Let's look at the profiler. High level. Time to unit, profile tracker. Yeah, let's go into OLP. Be right back. Okay. Profiler, profile tracker. Get frequency. Get standard deviation. Updates. Okay, so this does enable feature map. Quite big. Profiler. Let's look at the low level C++. Okay, so there is this notion of a program zone. Profile init. Profiler low level. H. So there is this notion of a program zone. Profiling in 64. Entry count program zone. This is probably a macro. Program zone. Is this a macro? Pound define program. No, it's not. What is this? Oh, is it the constructor? Maybe the constructor. I don't know if you do it like this. In C++. I think it's a constructor. Or two methods on it. So we have an enter zone. There's this zone stack. Zone stack. Max profiling, stack depth. Okay, when we enter a zone, okay, we put this on the zone stack. We set the ticks, okay, and when we exit, we decrement this. Okay. zone, exit zone, total self ticks. I wonder what the difference between zone T here and zone T start is. Or higher. Far. So we put the zones on there and we remove them. But how? T here start, T here ticks. Int initialized, int index. The stack. How is it evaluated? So profile, low level, CPP. So this creates a zone. Num zones. Okay. And how is this used? Zone, enter, enter zone. How would you use that? Suppose all the math is in here. We could try and do this as well. We could also do something else. Okay, they organize it as a stack so that you probably so you want to measure exclusive time in the zone. This is why they use the stack, I guess. You could also okay. So maybe what would be the approach? We don't really have recursive functions. Okay, what do we want to do? We want some way. So we want to enter a zone or whatever. We want to time a block. You can also rename this. So begin block or something. We want to begin a block somewhere, and then we want to end the block. And we can have several of these in here. Begin block and end block. And then what we basically have is we have one big chunk of time. That's our block A. A begins here and A ends here. We have another block, B, that starts here and ends here. B, B. What we want to measure is the exclusive time in A and the inclusive time in A. So inclusive time is basically very easy. That's just A dot end minus A dot start. But the exclusive time is the inclusive time minus the exclusive time of B. Yeah. So when we end a block and we sort of have a parent, we want to subtract our time, our exclusive time from the, or we want to add it to the children time or something. Okay, so we time profiler.odin. Okay, so first and foremost, we want something, so package profiler or profile, and we want something that is a profile zone, which is a struct, and then we have a enter zone proc, and we have an exit zone or zone enter and zone exit. When we do it the way that John Blow did it, I mean, we could just say, okay, this is from Jonathan Blow's profiler. This is okay. Basically, we want a start timestamp counter. We want an elapsed do we need something else? I don't know. Profiler low level. Oh yeah, we need, we have sort of the exclusive time and we have the inclusive. Or children time. Should this have a name? Should this have a name? Yeah, maybe it should. We don't have something like a const char star. I mean, we could make this a string. And then zone enter profile zone, or yeah, profile zone. Then we have to read TSC somehow. Zone.start TSC is equal to this. And zone.exclusive time is equal to read TSC minus zone.start TSC. Okay, so and when we exit, so zone, it's kind of this zones thing going on, which is a profile zone or zone stack. And this has a specific size, which is max zone depth. Oh no. What did they choose? Max profiling zones, max profiling stack depth, max zone stack depth, max zone stack depth. And here the zone is equal to zone stack, and we also need a stack position. Then we set the zone stack at the stack position equal to is that right? They incremented it. Why do they increment before? And why do we need the old zone? Oh, see, okay, so they use the old zone. Total self ticks. This is kind of okay. So total self ticks is basically this here, and probably they new zone. I don't know what they do here. total entry count. Why do they keep track of a total entry count as well? Zone.total entry count. Okay, I see. So there's also how many hits, hit count. Enter entry count. Zone.entry count plus equals 1. So we do it a little bit different now. So this is equal to the zone. Okay, so this is the start TSC, and when we exit, now we have to do we increment it here? Yeah, we have to, right? Stack pos. No, okay, so stack pos plus equals 1. And when we get here, we say stack pos minus equals 1. So the first entry will probably not be used. We set it to the zone. This is the zone exclusive time. Parent is equal to zone stack pos, and we say parent dot children time plus equals zone dot exclusive time. Okay, so then we also want to import // x86 intren. And here we need kind of read TSC. Read TSC. And this is an RDTSC. I don't really remember. Okay, so reads the current value of the processor's timestamp counter into the EDX EAX registers. The EDX register is loaded with the high order 32-bit of the MSR, and the EAX register is loaded with the low order 32 bits. So we have to OR them together, right? So to say OR, oh, is that correct? I don't know. So does it also clear the top 32 bits? I don't know. So it's EDX, no, EAX shift left EDX 32 or RDX. And then OR together RAX and RDX and return, I think. We would have to look at this. So in x86 intrin, we also have an add link name read TSC, read TSC, C calling convention externally defined. And then in profile profiler, this should work. I don't know if it does though. Max zones, max zone count. I think they also had something like this. Max profiling zones, okay. So maybe also profiler setup. Probably needs an arena. Okay. Let's rename this to zone. A profile zone. And profiler.odin. Now package profile. Then we have a profiler struct, which probably has the zones. Profile zones. Maybe also has an arena. It's import core runtime, or is it base runtime? Runtime. It's base runtime. And it's runtime.allocator. And then so new yeah. It doesn't need an allocator, right? It's gonna profiler init. And then the profiler zone count. And then profiler, you also need an arena. And then we make a profile zone with how many? It was max profile, max zone count, and arena. So this is profiler.zones, and the zone count 0. So zone new. So if the zone count, or you just make it a stat and make it an assert. Assert that the profiler profile zone. Assert that the profiler.zone count is less than max zone count. Results is equal to profiler.zones at index zone count and zone count plus equals 1 and return. Okay. So in our main, should we have it as global? I don't know. So how do we enter the zones, though? Profile scope. Define zone is a program zone. Profile scope var. Num zones, zone stack, zone pointers by index. Zone pointers by index. Define zone. They're probably stack allocated. Is that correct? See, this is define zone. Okay, so they define these zones globally. And then, how do they use that? Zone enter. There's enter zone. Profile scope var. Profile scope var. Profile scope var. Then it has a destructor. Profile scope. So scope, the line, and it calls it with __ x. Okay. I think this is something for another day. I think we leave it at that, and I will think about this again. Yeah. I wish you a nice Sunday. And we'll see.